So today's topic is flange coupling. This is the next type of coupling. Now here in flange coupling, it's a rigid type of coupling. So in this coupling, we have two separate cast iron flanges. Now each flange is mounted on the shaft and keyed to it. The faces are turned up right angle to the axis. Okay, you will understand this thing with the help of figure also. This will helps to bring the shaft into line and maintain alignment. The two flanges are coupled together by means of bolts and nuts also. So there are three types of flange coupling. One is unprotected type flange coupling, which we are going to see here. Protected type flange coupling and marine type flange coupling. All these three we are going to see today. First, the unprotected type flange coupling. Let's see this. Okay, these are the two halves. This is one half and this is the another half. And by with the help of color, you can understand this thing. So this half is inserted in this left side of shaft and this half is inserted in the right side of the shaft, and these two half are joined with the help of this bolts and nuts. So these are the flange and this is the hub. It is just a modification of a muff coupling. Okay, here the flange is added here, this much part is added here. Now let's see, this is the original figure of it. Okay, it's a CAD model. There is the bolt, there is the bolt, this is the flange and this is a hub. Okay, now the unprotected type flange coupling is shown in the figure last which you have seen, are coupled together by means of bolt. So here D is the diameter of shaft, capital D is nothing but 2 times the diameter of the shaft, which is shown here. Okay, dimensions are shown here, which is an empirical dimension. This is the capital D, and D1, that is the pitch circle diameter of this flange, which is nothing but 3 times the D. Then outer diameter of flange is nothing but 4 times of D. So all these dimensions are shown here, and length of key or length of hub is nothing but 1.5 times the diameter of shaft. So this is how all these things are mentioned here. Thickness of flange, which is shown here, TF, is nothing but 0.5 times the diameter of shaft. Number of bolts depends upon the diameter of shaft. If the D is up to 40 mm, then N should be 3, that is number of bolts should be 3. If it is more than 40 and less than 100, then number of bolts should be 4. If it is more than 100 and less than 180, then it should be 6. So this is how it is done. So these are the nomenclature for it. Now design for hub. So the stresses which are acting on it, it is shear stress and your crushing stress. These two stresses are acting mostly in the coupling. So shear stress for shaft, bolt and key both are different, and shear stress for coupling is C. It is different. Now design for hub. First we need to find out the diameter of shaft. Based on that we are going to do it. So first torque is needed. Torque is equal to what? The same torque which is used for the shaft will be used for the coupling. So T is equal to pi by 16 tau C d raised to 4 minus small d raised to 4 by capital D, that is for hollow shaft. Based on this we are going to check the diameter is correct or not. That means we are going to check here the shear stress for the coupling, and can design the key, because based on shaft diameter we can get the dimension of keys directly from the standard table. So just put that values here and check that values are safe in shear and crushing or not. If it is safe, then it is good, otherwise change the dimension. Then the next is the design for flange, which is important here. So flange design is nothing but it is equal to torque equal to circumference of hub into thickness of flange into shear stress of flange into radius of hub, because this flange is transmitting what? A torque. So pi d is the circumference of hub, Tf is the thickness of flange, tau c is the shear stress, and d by 2 is the radius of hub. So pi d square by 2 tau c DTF is the formula for it. So this formula is useful for designing the flange. Here DTF is all known to you. Here you have to check the crushing shear stress for the coupling. Now the bolts. Bolt, we know that diameter of uh, same formula which we have used for simple stress, that is stress is equal to what, load per unit area. So area is what, pi by 4 d1 square into tau b is the load on each bolt. So for number of bolts multiplied by n. Now torque is equal to what, force into perpendicular distance. Same thing is here also. This is the force, your load you can calculate, and this is the perpendicular distance. So here it is shown here. This is the formula for bolt. And we know that up to diameter 40, up to diameter 100, and up to 180 what we have to take. Based on this you will get a value of d1, that is small d1, that is the diameter of bolt, and that diameter we have to select from the table, that which, because threaded is a standard part. Now what is meant by protected type flange coupling? The design is same, but only a TP is added. That means a protection shield is provided here, and that TP is nothing but 0.25 times the diameter of shaft. So this is a protection shield cover. Okay. Now what is marine type flange coupling? In this marine type flange coupling, a pin is there, a quarter pin type pin is there, which is having a draft here. You can see the draft here, a taperness provided here, and this taperness having a threaded part after this, and it is joined in this way. One is straight and one is taper. Based on this marine works. And these are the number of bolts which is used for the marine shaft. Okay, I think you understand this part very easily. It's a very simple part. In the next we are going to see the numerical on flange coupling. Thank you.